All right, in this lesson, we're going to create an attack script, which at first will just be a punching motion, and we'll later use a Unity event called onCollision2D_enter to manage what happens when the enemy collides with our player's fist, right? So to start off with, let's just add an asset to our character folder for a fist, a sprite. So here in the cheesehead folder, import new asset, and as usual, set that to point. Not really much of an art asset, huh? Oh well, it'll do the job. So now we'll create the fist game object, and we'll parent it to the cheesehead. And it's going to need its own collision layer, so we're going to need to define that. So here we'll add the collision layer, calling it fist. And in the collision matrix, we'll set what collides with what. So let's see here. Well, we'll leave default for default game objects, but we can get rid of all these other ones here. And all we'll need is fist to collide with an eyeball, and that's it. So for the fist, we're going to need to give it a rigid body and set it to isKinematic to make sure that the parent, the cheesehead game object, is unaffected by the interactions. Otherwise, whenever a fist comes out and hits an enemy, it'll push back the cheesehead whenever there's that interaction. So let's set up all of the components here, including that rigid body. So for rigid body 2D, we'll have isKinematic. And actually, we're not using physics to move the fist. We'll just use lerp, so that's totally fine. Won't affect that at all. We'll freeze the rotation so it doesn't spin out of control. And that's good for that. And we'll also want a box collider. And I already figured out the size here, so I'm just going to input that here. You can always see that in the scenes pane if you want to. Right now our fist is invisible. So let's add a sprite renderer. And we'll put the fist there. Put on the player layer and put on the third ordering layer, so it'll be above our player. And just we'll put it close to our cheesehead for now. This will actually be determined in code, not in the inspector, but just so it looks all right when we're working with this, we'll just set this default value. And we'll actually scale it down, so that will be set in the inspector. This is important, so start scale down. And we'll have to put on the fist collision layer. And we'll create also the attack script. So make a new script, call it attack controller. Put that here in the player folder. Actually, before we go into the attack controller and setting that up, let's give ourselves another enum player state. So public enum attack. And right now we have either passive or punch for attacking state. And we'll also want to add it to our singleton for player state here, public attack. Also, we're going to need a a button set up for this. So again, we'll go to the input manager and we'll give it another axis. So turn it to 3. And here we'll call this one punch. And the positive button, we'll just set it to the V on the keyboard. Mouse button will be 0, so I guess a left click. All right, so turning again to the attack controller. In update, we'll start off by making the fist visible or invisible depending on our attacking state. So we'll say if player state dot instance dot attack is equivalent to attack dot punch, then we'll get component the sprite renderer and enabled equals true, else we'll make sure it's not enabled so that you don't see the fist. All right, now we'll just set up some fields in the attack controller. So we'll need a reference to the cheesehead game object, which we'll set in the inspector. Like that. A few more fields here. Float starting punch position. I like using descriptive names, especially for fields or when other people are reading my code, so that I'm especially explicit as to what I'm aiming at as much as I can be. So float ending punch position, int max pause. Sometimes you'll see people using kind of cryptic variables. I'm not a fan of that, even though they're a little bit longer. I just think they're easier to read. So that's why I'm using sometimes very long variables. We don't need start right now. So now we'll kind of utilize our button mapping for this and set the conditional for that. So if input dot get button down, it's called punch, and player state dot instance dot attack is attack dot passive. So this just makes sure we can't, keep rapid fire punching. We have to wait till our previous punch had completed. If that's the case, then we'll set these initial conditions. Player state dot instance dot attack equals attack dot punch. Starting punch position, we'll set it to the middle of our cheese head. Dot transform position dot x. Ending punch position, we'll set it to further ahead from the starting punch position by this amount. We'll say 0.7 units. And to make sure that it punches in front of us, we'll make use of that direction facing state. So player state dot instance dot direction facing. So it's either going to be -1 or 1. So we'll need to cast that to an int for that to work. And we're going to want the punch to remain paused at the full extension. So for that, we'll use the max pause field. Say max pause is 10. All right, so yeah, that sort of sets the initial conditions for punching attack. Now what we'll want to do is animate the punching attack, and we'll do this using the familiar lerp method, right? We could have just imported a sprite sheet for the animation, but I was just kind of honestly too lazy to do that, and this is maybe a bit more pure, just handling it in code, so we'll do it this way. All right, we're going to need some more fields here. So float punch motion, and we'll set it to mathf.infinity. So mathf_infinity is when you need some sort of uppermost floor or ceiling, I guess you could say. The opposite of this would be when you need a floor, an absolute floor, you'd use 0, right? So this is kind of the opposite of that. We'll need an uppermost ceiling, so we'll set it to mathf.infinity. And we'll need another one called attack force, attack pause, an accumulator for the lerp, and a bool called recoiling for when we reverse the animation, basically. All right, so now what we'll do here is we'll say if player state dot instance dot attack is equivalent to attack dot punch. So if we're in a punching attack state, we'll take the accumulator and start adding to it time.delta time. So on every frame, we'll just add a little bit more to it. We'll use that in the lerp later. And then we'll say if punch motion is, which we'll determine later as the output of the lerp, basically, if it's equivalent to ending punch position, we'll say attack pause plus equals time.delta time times 60. So as I mentioned before, at 60 frames per second, this will be roughly 1 on each frame. So it will pause by a value of 1 on each frame. And earlier we set max pause at 10, so you can probably figure out in your mind how this is going to work. So if attack pause is greater than max pause, and attack pause equals 1, we'll basically reset these values, so we're done with the attack pausing. And at the full extension, then we're going to want it to recoil. So we'll set the recoiling bool to true. And then we'll want to set the recoiling conditional. But actually, before that, I realize I could have just take this out here and leave it at the bottom of this. It's basically, it's the same conditional. So if recoiling now, actually, we'll start off with if not recoiling to set the motion of the initial punching motion, punching forward from the current position of cheesehead. We'll say punch motion equals what's returned from mathf.lerp starting punch position to ending punch position. And we'll use the accumulator now to basically set the rate of that, how fast that happens. We'll multiply by 7. We'll use this multiplier to make the punch faster or slower. And then we also want to set the local scale. So transform.local scale, we'll want to lerp it actually. So it kind of the fist kind of gets a little larger and just adds a little bit more of an interesting animation to the punching motion. So for that, we'll use vector3.lerp, and we'll go from the current transform.local scale to, well, we'll want to go to, we'll say new vector3 1 1 1. We'll have ending vector3 of that, basically an unmodified local scale. And at this rate, we'll just kind of lerp slightly slower than the punching motion itself. So we'll say accumulator times 5. So that's what's happening if we're extending our punching fist, and else if recoiling, basically, we'll do this. Punch motion equals mathf.lerp. We'll go from ending punch position this time back to starting punch position. And we'll go a little bit slower when recoiling, right? Not as much explosive force. We're kind of emulating with making the accumulator multiplier smaller than when we're extending our fist. And transform local scale, also want to lerp that right back to what it was before. Vector3.lerp from its current local scale to, what was it, 0.6 and 0.5 for x and y respectively. So we'll say new vector3 0.6 for x, 0.5 for y, and 1 for z. And accumulator times 4 when recoiling for this local scale lerp. And once we get back to our starting position, so with a conditional, we'll say if transform.position.x is equivalent to the starting punch position, we're no longer recoiling. And we're no longer tacking. Tack.passive, right? And might as well reset the accumulator as well. So we can do this all over again if we want to. Basically punch again, right? So finally, none of this actually does anything until or unless we assign it to the transform position. So say transform.position equals new vector3 punch motion, and we'll just pass in the cheesehead's y position because we're going to need it. Position.y and transform position dot z. So this makes sure that the fist follows the cheesehead on the y and as well on the x with punch motion that we've been determining up here. And for z, we just take the current fist transform position because the z value is for depth and we don't really need that. Okay, now what we're going to need to do is set the initial attack state in the player controller, and we'll also set up a block of code that limits our character's movement when attacking, basically preventing us from moving left or right, or jumping for that matter when we're attacking. So in the player controller, let's make these changes. Add the player state. So for jumping, we're going to want to limit this not only to having our y velocity having to be 0, but also be in a passive attacking state. So player state dot instance dot attack has to be attack dot passive. And for here, what we'll do is we'll basically wrap our horizontal motion dependent on whether or not we're passive or not. So what we'll do is we'll just create a conditional here in update. If player state dot instance dot attack is not equivalent to attack dot passive, we'll say cheese body dot velocity equals new vector 2, and we'll basically make sure that your velocity you stop to a halt on the horizontal axis. On the y-axis, we're going to put it to 0.1. Why not 0? Well, if we're at 0, then we'll theoretically be able to jump after we're done punching, right? Because we're even if we're in the air, right? So that's not going to be good. So we'll just give it a little bit of velocity on the y-axis to prevent that. But otherwise, basically prevents us from falling as well when we're punching. So we'll be suspended midair. I think it's a nice little mechanic, so it's easy enough to create. And, well, just to make sure, horizontal motion is also set at 0. And otherwise, if we're passive, basically, we'll say else, and we'll just stick all of this in the else clause. Basically accepting our user input, right? All right, so now hopefully that's all set up correctly and didn't make any errors. So let's see here. All right, let's first try, what is it, V? Sorry, look at our player state. All right, good. And there's our player state. It's correctly changing from passive to punch. Now when we punch our character, well, kind of nudges it a little bit because the colliders are just intersecting. But so what we're going to do now is we're going to fix that. Now what we'll want to do is use the add force method whenever our fist collider intersects with an enemy collider. So for this, we'll use the onCollision2D enter method, which is actually a method that's tied into something called an event, which is a C# concept that we haven't looked at yet, and we're not really going to look at too carefully. Not really going to go into events. It's outside of the scope of this material, or a related concept called delegates. But to give you a simple primer on this, a delegate is just a way of holding a reference to a method within a variable. That's pretty much it. And an event is basically a version of a delegate that's intent is to hold a reference to one or more methods that subscribe to it. That's usually the language you'll hear in reference to events. So whenever something happens and the event launches, which is basically like calling an ordinary method, it'll also call all of the methods that have subscribed to this event. So that's how events work. But you don't need to know all that. It'll probably be pretty obvious how this is working. All right, so for this, we'll go back to the attack controller, and alongside update, we'll also have this method that's tied into the event called void onCollision. You have to spell it exactly, so because this is a, just like update, it's a pre-made method, or it's a method that's part of Unity. So onCollision enter to D, and it takes in a collision 2D called call. And so here what we'll do is have a conditional. So we want to detect when the enemy and our fist intersect. So for this, I think I'll show you how to use a gamer, or a gamer tag, to use a game object tag in order to determine how this works with the on-collision enter 2D. So for the, see, it's untagged here for dummy game objects. So we'll set a tag here to enemy. We'll see why this is useful. Here in our on collision enter 2D, we'll just say if call, so this takes in the collider of the other collider, basically, that our fist collider is interacting with. So if call dot game object, so we're referencing the game object property, dot tag is equivalent to, oops, enemy. So this will limit this effect only on when our fist interacts with enemies. If that's the case, then call.gameObject.get component, so we'll get the rigid body of the enemy that we're colliding with, and we'll just use this dot accessor to right away just use the add force method, which will say mu vector 2. We'll just assign something here for now. Well, first we'll want to create a force on the x-axis relative to the direction we're facing. So we'll just say, player state dot instance dot direction facing, and we'll cast that to a float to make this work. We'll multiply that by the attack force that we had set up previously as a field. So on the x-axis, we'll create a force of the amount attack force, which I forget how much we set it to. Well, we didn't set it. Oh, we will. All right. And then for the y, we'll just we'll just push it upwards. So we'll use attack force. Don't have to worry about minus or plus values like we had to for the x value. And we'll use again force mode 2D.impulse. All right. This is too long of a line, I think. So what we'll do is put this here. And I think I have an error here because of a missing parentheses. So we'll say u vector 2 on that line, attack force on that line. Oh, whoops. I had an extra parenthesis, more than I needed right there. I'll need one here. Boy, that looks bad. Put this here. Yeah, that looks better. Although far from perfect. Hopefully you understand what's going on there with my line separation. Looking a little ugly. Sorry about that. All right, so for attack force, I'll just set this all up in a initial state and start. So we'll say attack force equals 5. We could play around with this and see what's the large or the best force to add later on. And I'm not sure if we set the attack pause. Should be okay, but I'll set it here to 1 anyways, as well as the accumulator equals 0.02f, just to these initial values. And just for consistency's sake, let's also put punch motion set to mathf.infinity there as well in the start for our initialization for all of these fields. Yeah, we set max pause there. So yeah, okay, we're good. So let's see now what happens when our fist collider collides with our enemy collider. Should be adding a force now. Yeah, there we go. All right, pretty good. All right, just to expand a little bit on events, even though we're not going to get into it, what's happening here is, in your mind, you can picture whenever these colliders intersect, the fist collider and the eyeball collider, the event that this method on collision enter 2D is sort of attached to or subscribed to launches, which in turn just calls this method, right, that's subscribed to it in the background in Unity. You know, it's a predefined event that's subscribed, or this method subscribes to in Unity. So why use events? Well, events are a good way of executing code without having that code constantly see if it should execute by polling, right? By poll, I mean something like how all of our mono behaviors all have their own update method that, say, would run a conditional check on every frame, polling on every frame and asking sort of a question like, are the conditions met for executing this or that method? And it does this over and over again. So with an event, you can have a bunch of methods that, you know, perhaps should all execute when a particular conditional polls as true in an event or an update method somewhere, which is much better than having, say, multiple update methods in the same class of each method that should execute, basically polling the exact same thing. It's just a lot more efficient and clean to tie all those methods to a single event that all execute based on a single polling. So it just makes more sense logically and computationally, but events are just a little bit trickier to get your head around when looking at its guts in you know, how events and delegates are structured. So that's why we're not going to go into it any more than we are right here with a couple of these pre-created events and methods that you have available to you in Unity. Thankfully, you don't even have to fully understand how events and delegates work to make use of these pre-existing events in the Unity engine. So with that, we'll end this lesson, and in the next lesson, we'll move on to creating a projectile attack. See you there.